Hi viewers, I welcome you all on my channel Maths Gurpreet. Let's proceed with the same topic polynomial. Basics I have uploaded in last videos. You can check from there. Let's see today 0 of p of x or root of this equation p of x is equals to 0. So when only polynomial we are taking, it will be known as 0. When we are taking this equation p of x is equals to 0, the name is what then? It's called root of px is equals to 0, this equation. So let's see, if I have this polynomial p of x and c is a real number such that p of c. So we are putting the value of x as c and the result, if the result is 0, equals to 0, then c is called 0 of given polynomial px or root of p of x is equals to 0. Let's take an example. Say if p of x is equals to 2x plus 3. So if they are asking to find 0 of p of x is equals to 2x plus 3, we will just equate this px to 0, then 2x plus 3 is equals to 0, 2x is equals to minus 3, x is equals to minus 3 by 2. This is giving us the 0 of p of x. Other way they can ask, check whether minus 3 by 2 is a 0 of p of x that is equals to 2x plus 3. They can ask us to check it. So what will we do? We will just put the value of the 0 in x or the number in the x, and if the result is 0, it's minus 3 plus 3. Ultimately result is what? 0. So clearly p of minus 3 by 2 is equals to 0. So this minus 3 by 2 is satisfying this condition. So we will say yes, minus 3 by 2 is a 0 of given p of x. So this was all about 0. Video with several other points had uploaded by me on this topic 0 of polynomial. You can also check that video for details. Next is when we have to divide a polynomial by a linear polynomial. So if I have this polynomial p of x of any degree greater than equals to 1 and I have to divide this polynomial with g of x, a linear polynomial, then how will we do this? So there's a method called long division method. Long division method. Let's take an example. Say p of x is equals to 3x square plus 3x square, say, plus x minus 1, and g of x is equals to x plus 1. So clearly g of x is what? A linear polynomial, and p of x is a polynomial of degree 2. So all about the linear polynomial, degrees, binomial, monomial, all these concepts were given in the basic video for polynomials. You can check the concepts from there. So what we will do, we will just take this p of x as dividend and g of x as divisor. So if the polynomial is not arranged in the descending order of the exponents, we will first arrange the dividend in the descending order of powers. Here it is already in, so there is no need for such arrangement. So what we will do, we will, after arrangement, we will take the first term of the dividend, divide it with the first term of the divisor, and after cancelling this out, we are left with 3x. This we have to write in the quotient, and we will multiply this 3x with divisor. Divisor it what? X plus 1. So after multiplying, we are getting 3x square plus 3x. So 3x square plus 3x. Now we will change the sign. We can cancel these out. Now minus 3x plus x is minus 2x minus 1. From here we can write this is the new dividend. So divide the first term of the new dividend with the first term of the divisor. We are getting minus 2. So write this minus 2 here and multiply it with the divisor. We are getting minus 2x minus 2. Minus 2x minus 2. Change the signs. We can cancel these out. We are left with 1. So here this is a constant. Degree of a constant is always 0. So degree of this remainder is less than the degree of this polynomial. Here degree is what? 1. Here degree is 0. So this constant is what? Remainder. So this is our remainder. This is called the long division method. Every question, such question can be performed with this method. So next is the remainder theorem. Very important theorem. This is the topic of 9th standard, but there is such results we must learn or we must keep in mind for interviews purposes also. So what is the remainder theorem? Remainder theorem. It says if Px is a polynomial of degree greater than and equals to, Px is a polynomial of degree greater than equals to 1 and a is a real number. What is the role of a? Here gx is another polynomial x minus a linear polynomial x minus a. Then if we divide px by this gx x minus a, if px is divided by x minus a, then remainder will always be p of a. So if we have two polynomials satisfying these conditions, that degree of px is greater than equals to 1 and the second polynomial is linear, then we can just put this value here in the first polynomial or dividend. We will get the remainder. This is the remainder theorem. So let's check the proof for this theorem. Proof is very simple. We will just write what we are having right now. So if px is a polynomial of degree greater than equals to 1 and we are dividing this px by gx. So on dividing px by x minus a, we can write this dividend as product of this divisor into some quotient, take it as qx, and plus some remainder, take it as r of x. So clearly in the long division method I have told you that degree of this remainder will always be less than degree of this divisor, that is x minus a. So degree of x minus a is what? 1. So less degree from 1 is what? 0. 0 degree means that rx is constant. So clearly rx will be equals to r, that is equals to constant. So we can put the value here. We will put the value of rx, r in this equation. So px is equals to x minus a qx as it is plus r. So this x can have any value from the real numbers. We will take a particular case when x is equals to a is from real numbers. So we will take x is equals to a in this above equation, q of a plus r. So a minus a will give us 0 into q plus r. So we are left with r. Ultimately we are having this result. In the end we are having p of a is equals to r. Hence proved. This was the theorem. Theorem was saying that on dividing this with this polynomial, we can directly write the remainder just by putting the value of a in x. In x we will just put the value a. So I have proved that when we will put the value a in the given polynomial, we will reach to the remainder. So hence proved. Very simple proof. I hope you get it very clearly. Hope you understood. So let's move to the question related to the remainder theorem. So if we are having two polynomials that are satisfying the conditions that dividend is degree is greater than equals to 1 and for the divisor it is linear, we can directly write the remainder. For example, if I am having this polynomial x cube minus ax square plus 6x minus a, if this is our p of x and q of x is x minus a, we have to find the remainder. Find the remainder. So we'll see here, first polynomial is of degree 3 which is greater than equals to 1. Fine. This is a linear polynomial. Fine. So here we will equate this second gx. Take it as gx. Gx is equals to 0. So we will get the value of x as a. Now this value of x, that is a, here we will put in the dividend and we will get the remainder directly. So a cube minus a into a square plus 6a minus a. A cube minus, this is 1 plus 2, base is same, powers will get added, 6a minus a. So this is 0, we can cancel this out and 6a minus a is 5a. So p of a is equals to 5a, which is the value of remainder here. So the result from the remainder theorem has been applied here. Let's see one more example. Let me write here. If I have the polynomial p of x is equals to x cube plus 3x square plus 3x plus 1 and g of x is equals to 5 plus 2x, and we have to find the remainder here. What we will do, just degree is 3 which is greater than equals to 1 and this is a linear polynomial. We can write down, we can use the remainder theorem here. We will just equate this gx to 0 to get the value of x first. So 2x is equals to minus 5, x is equals to minus 5 by 2. Just put this value x is equals to minus 5 by 2 in this polynomial and get the result. We will get p of minus 5 by 2, whatever you will get, you will have your remainder as answer. So this was all about the long division method and remainder theorem. Next we will see the factor theorem. So factor theorem is basically coming from the remainder theorem. I have uploaded a full video on factors and multiples, HCF, LCM. If you have any doubts regarding factors or multiples, you can go through that video. So what factor theorem says? It says if px is a polynomial of degree greater than equals to 1, same it is saying, and gx is a linear polynomial. If px is a polynomial of degree greater than equals to 1, a is a real number and gx is equals to x minus a is a linear polynomial. Number one is x minus a is a factor of p of x if p of a is equals to 0. Second is p of a is equals to 0 if x minus a is a factor of p of x. So on dividing this by this, we can write this as p of x dividend is equals to divisor into some quotient plus this constant r from the remainder theorem, which is basically what in the next line, which is basically what p of a. Here we will write by remainder theorem. this line. So first is if P of A is equals to 0, we will put P of A is equals to 0. We are left with x minus A into qx. So this P of x is, this gave us x minus A is a factor of Px. Why? Because remainder is 0. This is the definition of factor, exact divisor. So second is, if x minus A is a factor of Px, then P of A is equals to 0. I am leaving this part for you, it's very easy. You can prove this and complete the theorem. Let's check a question related to this theorem. So the question is, find the value of k, find the value of k if x minus 1 is a factor of, if x minus 1 is a factor of this polynomial kx square minus root 2x plus 1. So this is the question. Solution. So if x minus 1 is a factor, from the factor theorem, we have, what we have, it's saying x minus 1, if x minus 1 is a factor of, let's say this is P of x, then factor theorem says then P of 1 will be equals to 0. Or factor theorem says P of A, so here is 1, P of 1 is equals to 0. So we will put the value x as 1 here. K 1 square minus root 2 into 1 plus 1, we will equate this to 0. K minus root 2 plus 1 is equals to 0. So k is equals to, root 2 will be positive now and 1 will be negative now. So this is the value for k. This was the question, find k if x minus 1 is a factor of this. So x minus 1 is a factor of means we have to use here the factor theorem. And what factor theorem says, if this is a factor of some polynomial, we will put the value of this a here and this will be equals to 0. That means remainder is 0 because this is an exact factor of the given polynomial. So I hope you understand all the concepts very well. Hit like if you are liking my videos and subscribe to my channel and share it with your friends. Thank you for watching. Have a good day.